We're going to look at a small demonstration of how to get OpenLineage to write directly into Delta Lake. So the idea is we're going to have some SQL scripts that are going to be running inside of a main app. And OpenLineage, the jar, is going to be listening using a Spark listener, which is the default demonstration OpenLineage gives you. And the piece of innovation in this demo is that I've spun up a Spark driver plugin and an executor plugin, which is going to be hosting two REST APIs, one on the executor, one on the driver. And the idea is we're going to tell OpenLineage listener to send the lineage to this local REST API, which is going to use a Spark plugin RPC client to send messages to the driver. So for example, if we have hundreds of executors, they're all going to be sending messages to the driver. And we have a concurrent safe buffer that the receiver is going to be writing to. And then when our ETL is done, we're going to have our main app basically send a flush REST API call to our driver plugin, which is going to flush the buffer with all the data into Delta Lake as a single transaction. So we get a nicer Parquet file. And then the idea is we can basically go ahead and have a script that can read from the Delta Lake with the original JSON files and then replay that to an OpenLineage compatible UI like Marquez. And then we can see what the lineage looks like. So let's go ahead and take a look at Spark inside of this VS Code dev container. So the only piece is we're going to be using the same version of OpenLineage, which is going to be present in Fabric. I'll show you. And we're going to go ahead and have that OpenLineage listener send to an HTTP endpoint, which is going to be our executor plugin, the REST API port. Then I'm configuring my Spark plugin, which I call HTTP dumper plugin, to spin up a driver port and an executor port, and then send data to this REST API. So let me go ahead and start Spark using Spark submit, and we're going to start debugging. So let's go ahead and run that. And we're going to start the debugger, which is going to start here. Okay, so we're inside the main app, and basically we're going to read some CSV files from the internet and then just like run some SQL statements to do a bronze, silver, gold type thing. So when the Spark session starts, what we're going to find is our plugin code is going to get invoked by Spark. So there's basically two plugins. There's an executor plugin, which is here, and there's a driver plugin, which is here. The code is quite simple. So let's go ahead and just run the Spark session. So the Spark session is spinning up, and we see that we are inside the init method of the driver plugin. So this is basically how the Spark API calls work. And then after the driver plugin is spun up, Spark goes to each executor node and invokes the init method on each executor. So basically what I'm doing is when these init methods are being invoked, so for example, let's look at the executor plugin, I'm just spinning up a REST API using nano HTTP, and then I'm putting that REST API inside of a thread. So if you look at the REST API, like I basically just go ahead and listen on all routes, and then regardless of what route the message comes in this case with OpenLineage, we're basically just going to go ahead and make a call to the plugin context. So if I go back to this diagram, when the OpenLineage is going to be sending us data, we're just going to send it over to the buffer here. So let's go ahead and just go ahead and debug through this a little bit. So we can see that as we ran the Spark SQL statement, we got a REST API call from the plugin. So if I were to go ahead and go to the plugin context send, you'll see the metadata that we're sending is basically the data that OpenLineage is sending us, right? So this is the request body that OpenLineage, the Spark listener, is being sent. So the idea is every time we run a SQL statement or some sort of like something that is causing Spark to do some query processing, whatever is happening is going to be sent via OpenLineage to this endpoint. And then like from here, if I go from plugin context.send and I keep debugging, you will notice that it comes into the receive method. So if I so this is basically on the this is the receive on the driver plugin. So basically this is that plugin, and then we're just going to put stuff into our buffer, and then off we go. So this is kind of the only thing that's interesting. So I'm just going to disable all the breakpoints or remove all breakpoints, and then I'm just going to go ahead and let this run. So okay, so we can see that Spark is going to go ahead and, you know, create the customers, orders, so on and so forth, and then just create all these tables and then do the ETL. So there's nothing more interesting that's kind of going on. As these tables are being created, we see that if I go to my local Delta Lake, we can see these are the tables that are being processed. These are just regular old Delta tables. And then when, so if you look at the end, after the ETL was done, I have my main app just sending a flush call to the flush API. And then we see that the REST API sent, okay, we flushed 46 messages. And this is at the end of the flow where we now see we have that data ops inventory DB. This is where we're going to have the OpenLineage payloads. So now what I can do is I can, like if I want to visualize what this data looks like, I have just this very simple script here, which is going to go ahead and just run a select request body from that Delta table. And I'm just going to go ahead and write all of that into like a simple JSON file. So the idea is, so while this is running, you know, when this is going to be running in the cloud, which you'll see shortly, if I'm interested in a particular table's lineage or something, you know, I can go ahead and just run a regular old Delta query, get that data out, and then I can visualize it using Marquez. Now, obviously, in the future, it would be good to have this visualization right inside Fabric, but the point I'm trying to make is we're decoupling the metadata lineage collection versus the actual serving that's going on by using Delta Lake as a persistent buffer. So we ran this query, and then if I go to .temp and I go to OpenLineage, you will see that these are the kind of 46 messages. So if I go back to my, you'll notice that we did the 46 messages, and those are the 46 messages. So now if I take those 46 messages, I have this other repo. This is OpenLineage Sandbox. You can find it in my GitHub. And basically what I'm doing is I'm going to spin up Marquez. So, you know, I'm just git cloning Marquez, and then I am using their built-in Docker script in order to basically go ahead and spin up Marquez. So that's what this is doing. And then what I'm going to do is I'm going to store the lineage that we got out of that other repo inside of, you know, this repo, which has Marquez in it. And then I have a very simple script, which is basically going to go ahead and like read every line of this, you know, lineage, and then you just send it to Marquez. So as far as Marquez is concerned, it's actually OpenLineage is like sending the data directly to Marquez, right? But what we managed to do is basically buffer using Delta Lake so that, you know, we can decouple our serving layer. So we can have hundreds of jobs that are all writing to Delta Lake, and, you know, we can basically go ahead and visualize when we need to, or run some Python analysis. So Marquez is spun up. So if I go to my laptop here and I go to just spin up Marquez, you'll notice that there's no jobs found, which is as expected. And then what I'm going to do is I'm going to go ahead and use this script to send data, and you can see that Marquez is basically getting those calls from the script. And then when this is done, we go to our UI, and I do a refresh once again, and we can see that all of that metadata got hydrated. And then I come here, and let's say I want to view the column level lineage for this, or this is not the column level lineage, this is just the, you know, regular lineage. And then if I want to see the column level lineage, I can go to the dataset view and click on column. And you can see that the actual SQL statements that we ran, right? So for example, this is customer cleaned. If I go to my code over here, you will notice that the actual query that we ran here, right? These three queries from whatever table with whatever join, is essentially what Marquez is showing, right? So this is the column level lineage. So now at this point, we can go ahead and show that this exact same kind of demo ETL that we just ran is going to work exactly as you would expect in Fabric. So if I go ahead and go to Fabric, I just have all of this set up. So the table doesn't actually have anything. So if I go do a refresh, you will notice that our OpenLineage table or our ETL table doesn't have anything. I have the executor plugin, you know, that plugin code that we had. I installed it on my Spark cluster. I don't have anything else because OpenLineage, as you're going to see, is already installed into Fabric Spark. And then in the Spark properties, what I'm doing is the same things that you saw in Bash. I'm just going ahead and putting this in during Spark Summit. And then what I'm going to do is I'm going to just run that demo ETL with the same config file in the args and then mounting those two lakehouses. So let me go ahead and click run. and just wait for this to spin up. This was the previous test that I did. So the job is starting. Let's just wait for it to go ahead and finish. So in the meantime, while this is running, let me just show a run which was successful to show the OpenLineage that was already pre-installed inside of Fabric Spark. So if we go ahead and look at the Fabric UI for a previous run, and we go to environments, you will notice that OpenLineage is already pre-installed in Fabric Spark. It's in 1.2.6. And you will notice that there is already certain properties that are in place inside of Fabric Spark. The piece that we overrode is this 19001. That's our executor plugin HTTP request. So basically, we're just overriding the OpenLineage behavior, so it works as we would expect. And so this is starting. I'm just going to pause until this job is done, and then I'll show the lakehouse that's hydrated. Okay, and the Spark job is done. And if we go to our lakehouse, we notice that those ETL tables are created, and then our table with the OpenLineage metadata is all here. So if we want to, for example, see what the I guess I can't show the actual JSON, but basically the actual JSON that was created by OpenLineage listener are all stored here. It's basically an HTTP dump table, as the name suggests. And then we can just do a spark.sql.read of request body, serialize that back as JSON, and then I can just go ahead and take that JSON, put it back into Marquez, replay it, and then I'll be able to have my lineage. In the future, I could probably go ahead and take the Marquez UI and host it using Fabric Extensibility Toolkit using TypeScript or something like that. Cool, that's it. Thanks.